kind of increasing. This is called the concave up, right? This is a concave down, all right? So now how do we describe these two kinds of increasing functions, right? We use the second derivative, right? So if the second derivative is greater than 0, then the function is concave up, right? Now if the second derivative is smaller than 0, it's concave down, right? So anyway, so that's why that's how we're gonna find a third condition here, all right? So in that sense, all right, so P2 will be a better approximation than P1 because P2 not only satisfies these two conditions, and P2 will also satisfy a third condition. All right. So now here, how do we find this P2? All right. So we want to build on we want to build on P2 from this polynomial P1. So we just add a term to P1. All right. So let P2 be P1, which is f of a plus f prime of a times x minus a plus another term. So this term is given by this. So C2 times x minus a squared. All right, so C2 is still need to be determined. All right, so here we will see why we add this term to this polynomial P1. All right, so we will find out this real soon. All right, so anyway, so here we want P2 to satisfy 1, 2, condition 1, 2, and 3, which is the second derivative of P2 at the point A is equal to the second derivative of this original function f at A. All right. So here is the third condition. All right. So now let's find out what is this coefficient C2. All right. Because once we decide what is the coefficient C2, this P2 is defined. All right. This polynomial P2 is defined. Okay. All right. So here, let's check. First of all, let's check. If we define P2 this way, does P2 still satisfy these two conditions? So let's check that real quick. So now here, so for the first condition, right, so what is P2 of A? So P2 of A, so simply just substitute x by A. So what do we get here? So it's f of A plus, all right, so A minus A, so this term is gone. All right, so here, once again, A minus A, this term is gone. All right, so P2 of A is equal to f of A. All right, so first one check. Second one, so now let's look at the first derivative of this P2. So P2 prime is equal to what? So by the way, so P2 is a function of x, right? All the other things are just the numbers, all right? So it's constant. If we take the derivative, that's gone, all right? So now here, what's the derivative of this term? Simply just the f prime of A, right? You see that? It's a linear function, right? So we take the derivative of this term, simply just put the coefficient in the front, all right? So now take the derivative of this linear function, that's simple, all right? So just one. All right, anyway, so what's the derivative of this one? So use the power rule, right? So we have 2c2 times x minus a, right? You agree? All right. By the way, so this is a function of a composition, right? Do you see that? That's a function of composition. It's not simply just x squared. It's x minus a squared, right? So, but for the derivative, that's the same, right? Okay, anyway, so that's the first derivative of this P2. Now, what is P2 prime of A, all right? So P2 prime of A, so this term is gone, right? Because A minus A, 0. All right, so the second condition is still true for this P2. All right, so now let's check the third condition. All right, so the third condition, we need to find the second derivative of P2. All right, so how do we find the second derivative? We're going to find the derivative of P2 prime, right? That's the second derivative, right? Okay, so now what's the derivative of this function? So what about this? What is f prime of a? By the way, f prime of a is just a number, right? F prime of a is a number. It's given, all right? So if we take the derivative, that's 0. Right? So now what's the derivative of this? 2c, right? 2c. So P2 double prime of x is equal to 2c2. All right? Now then we evaluate this second derivative at the point A. All right? So by the way, so you see that we have to have two steps, all right? So to evaluate the second derivative of this P2 at the point A, first of all, we need to find what is the general formula for this second derivative. And then we need to plug in this A to evaluate this value, to evaluate this function. All right, so P2 second derivative of A, that's equal to what? Just 2c2, right? Because that's a constant function, right? 2c2. Now, by the way, so we still don't know what is c2 yet, but we want this P2 to have this condition, which is the second derivative of P2 at the point A is equal to the second derivative of f at the point A. All right, so now in order to have this condition, we need to equate this number 2c2 with the f double prime of A. All right, so now this gives us c2. So c2 is f double prime of A over 2. All right, so we see that without knowing this coefficient C2, we already know, we can check that the first condition, second condition are still true for this polynomial P2, this quadratic polynomial, all right? Now, in order for the third condition to be true, all right, so C2 has to be equal to this, all right? So C2 is determined by this function f. Anyway, like remember, we're trying to use P2 to approximate f. So P and f has to be related in some ways, right? So anyway, so that's C2. So now I can write out this P2. So P2 is equal to f of A plus, and then plus f double prime of A over 2 times x minus A squared. All right. So that is a general formula for this quadratic polynomial P2 approximating this original function f. That's a very general formula. You see that in all of these processes, we didn't use anything about the function f. Right? So we just assume that we know f of A, we know what is f prime of A, and we know what is f double prime of A. All right? So assuming those things are relatively easy to find. All right? So now we can find a polynomial P2 to approximate this original function f. All right? So now this is called the quadratic approximation for the function f. All right? So now let's look at the example. How do we use this to approximate a complicated function? So look at example 1.1. All right, so let's look at example 1.1. So let's use the linear and the quadratic approximation to approximate the square root of 17, all right? So like, we don't want to use the calculator, all right? So we want to just use the basic arithmetic to evaluate this value, square root of 17. All right, so one thing is easy, right? We know what is the square root of 16, and that's equal to 4, all right? So that's very easy. Now what about square root of 17, all right? So 17 is very close to 16, all right? So first we have to identify what is the function that we're trying to approximate. So here, can you see what is the function here? What is the function f? Square root. Yes, exactly. Square root of x, right? So we're trying to approximate this function, right? So it's not a polynomial, right? So it's not easy to calculate square root of 17, right? Because without using calculator, how do we calculate this, right? It's not easy. All right, so now let's find a linear polynomial. Let's first find a linear line to approximate this number. All right? So now, first we need to find that point, A, right? Remember, to use a linear approximation or a quadratic approximation, first we need to know what is A, what is point A, right? So the point A should be something that's easy to calculate if we plug into the original function f, right? That's what I wrote here. So our A should be 16 because square root of 16 is very easy. All right, so now our A is 16, all right? Now, what is the linear approximation, all right? So what is the polynomial P1, all right? So f of A, in this particular case, so A is equal to 16, and f of A is equal to 4, all right? F of A is equal to 4, A is equal to 16. Now, what is the f prime of A? So first of all, f prime of x is equal, use the power rule here, so that's 1/2 x to the negative 1/2. All right, so that's the power rule. So now, can we still calculate f prime of A? I mean, we should, right? We should be able to calculate that because we're gonna need that in this formula. All right, so okay, so if we plug in 16 here, all right, so what do we got? So it's 1/8, right? It's 1/8. All right, so now we can write out our formula for P1. So P1 of x is equal to 4 plus 1/8 times x minus 16. That's our P1. Now let's use P1 to approximate this value, the square root of 17. All right, simply just plug in 17 here. So P1 of 17. Now let's say, okay, 17 is pretty close to 16. All right, so not that close, but it's relatively close. All right, so P1 of 17 is equal to 4 plus 1/8 times 17 minus 16. And this is equal to 4.125. All right. So here, what we have, right, is just subtraction, addition, and the division. All right. So none of this need a calculator. All right. So if we want, we can do all of these by hand. All right. So anyway, so P17 is equal to 4.125. By the way, so if we do use the calculator, square root of 17 is equal to 4.125